Okay, let's go to do this problem. This problem is a problem 25.30 from your textbook, but if it is not in your textbook, do not worry, it's a very easy problem. It has two batteries, one of 16 volts, so the battery of 16 volts is pulling charges in this direction, creating a current in this direction. The battery of 8 volts is creating a current in this direction. At the end, the energy per unit of charge that the 16 volts battery is giving clearly will win, so the current you expect to go in this direction. It will go counterclockwise. Okay, so let's go to do the problems. Imagine that the current is counterclockwise. Let's say later we'll do it, imagine that we didn't pay attention to this. So we start at the point B. At the point B, okay, when I go from here to here, I gain 16 volts. When I go from here to the point A, I lose 1.6 I, the current. I don't know the current, but I lose potential. When you are moving from V to A, you are moving in the direction where the potential decreases. Now the potential again decreases an amount minus 5I. Now it will decrease minus 4I. Now you see you are crossing this battery in the direction plus minus. When you cross it from the minus plus, you are gaining. Now you are losing minus 8, minus 9I, and I come back to the initial point B. Okay, let's go to write the equation. So I start at the point V, I go through here. Gain 16 joules per coulomb. Lose 1.6 by I. Lose 5 by I. Lose 1.4 by I. Lose 8 volts. Lose 9 by I. Total 0. What I have in gaining? Well, gaining 16, I lose it. So what is the current? The current I will be 16 divide, 16, yes, divide, I see 1.6 here, 5, 1.4, 9. So if I solve the equation, it will be 1.6, the 1.4, the 9, 16 minus 8, it will be 8 divided by 17, so the current will be 0.47, and it will be in the direction counterclockwise because I have moved in this direction and the current has been positive. What happens if I move in the opposite direction, in the clockwise direction? What equation I will put? Let's go to move in the clockwise direction and to write the equation. So if I move in the clockwise direction, the current I that I will obtain will be minus 0.47, meaning that the current is in the opposite direction. So you can do it. Let's go. I write the equation and you solve it. So I'm going to move, for example, from here, starting here, gaining energy, losing energy. 9 by I will lose. So if I start as I said here, I gain 8 joules per coulomb. I lose 1.4 by I because I'm supposing that the current is being taking place in this direction. I am supposing that the current is taking place in the clockwise direction. Okay, minus 1.4I, minus 5I, minus 1.6I, that is the losing, passing through the resistance of 1.6, I lose energy per unit of charge, 1.6 now. I'm going to pass from, I lose minus 16 volts, minus 9i, and I came back here at this point, here. I am now here. So the gaining should be equal to the lost, so equals 0. So if I solve this equation, should be minus 0.47, indicating that the current is not clockwise, it's counterclockwise. Okay, so we have solved the first part. I hope it is clear for you. The second part say B, the terminal voltage B sub A, B. So B sub A, B means V sub A minus V sub B. And we are going to move through the resistance and through the potential of the battery of 16 volts. So the question is like this. We have discovered that the current is counterclockwise, is in this direction. Okay, is in this direction because we have discovered that the battery of 16 volts is pushing more charge per unit, more energy, is giving more energy per unit of charge to the particles, so the current is in this direction, is counterclockwise. So when I move from here, at the beginning I gain energy per unit of charge, and then I start to lose it if I move it from here. But if I move from A in this direction, I gain is energy per unit of charge. So I will gain 1.6 by I, and I will gain 16 volts. Okay, let's go to write the equation. So the easy way to do it is maybe like this. You start at the point V sub B. When you cross and you move in the direction of the current, you gain 16 volts. When you keep walking, you lose the quantity R by I. And now you are at the point V sub A. Okay, so the potential in V plus 16 minus R by I is the potential in A. So I will calculate this everything. I know that is 0.47. So 16 minus 1.6 by 0.47 is 15.2. So, and this equation, what it's saying is that V sub A minus V sub B is this. So V sub A minus V sub B is 15.2 volts. And now the third part C, is about the potential V sub A C, that is V sub A minus V sub C. So we start at the point V sub A. The current is going in this direction. Okay, so we lose the quantity 5I, and we lose the quantity 1.4I, and we lose the quantity 8, and we are at the point V sub C. So V sub A minus V sub C is 5I plus 1.4I plus 8. So I have to plug in that data. V sub A minus V sub C. As you see, you are starting at point V sub A that is higher potential, and you are losing potential when you are moving in the direction of the current. Moving in the direction of the current means moving to a direction where the potential decreases. So V sub A minus V sub C is positive because V sub A is bigger than V sub C. So, and what it will be this amount? It will be 5 by 0.47, I think, plus 1.4 by 0.47, plus 8. And V sub A minus V sub C will be will be, if you make the calculations, will be how much? Let me see, 5 by 1/2 is 2.5, more or less, plus 1.4 plus the half, 0.7 plus 8 will be 2.4, 3.2, 8 with 11.2 volts, more or less. I think so. Well, let's see. Maybe it will be 11 volts. I don't know. Multiply correctly by 0.3. So the problem is done. The part C is using the figure 25. Part D is using the figure 2520 as a model graph the potential rise and drops of the circuit. So we start at the point V. So this is the potential as a function of the point. So we start at the point V. Let's say that the potential at the point V is 0. So we move a little bit and we are in the potential 16 volts. When crossing this, we are at 16 volts. Now from the 16 volts, we are reducing. First reduction is 1.6 by I, 1.6 by 0.47. I don't know how much. You will be here. And now you are here. Now second reduction is 5 times 0.47. Third reduction is 1.4 by 0.47. And last reduction, 8 volts. And the last one is the one that takes you to the 0 again. That is 9, this one, by 0.47. And you are here now. That is the same potential that here, 0. And you start again. The battery will give you the 16 volts. And you will be decreasing like this. How much is this quantity? Please, you do it. 8 volts. When you pass here, you decrease 8 volts, okay? You finish the problem, very easy. Well, maybe we'll do it. So 1.6 by 0.7 is the reduction in the potential in going from here to here. This will be 0.8. And now 5 by 0.7, I'm here. The reduction will be 2.5, approximately. Now the reduction here, 1.4, I will say, it will be 0.7 approximately. Now we reduce 8 volts in passing through the battery, 8 volts, and now we will reduce again 9 by 0.7, and we are at the point B again. 9 by will be like 4.5. So the reductions are negative, of course, going down, negative, reduction. So you stay, the sum should be 16. This sum approximately should be 16. Okay? It will not be 16 because I multiply by 0.5 instead of 0.47.